In this episode of the .NET 5 REST API tutorial, we talk about unit testing, test-driven development, and how to implement them to raise the quality of our REST API. Today you will learn what is unit testing and why it is so important, what is test-driven development, also known as TDD, and why you may want to consider it in your projects, how to unit test a REST API controller via the xUnit testing framework, how to mock dependencies via the mock framework, how to write better assertions via the FluentAssertions library, and how to implement TDD in practice. So what is unit testing? This is a topic that I'm very passionate about, and to understand it, let me introduce a quick analogy. Imagine that you're a member of the team in charge of testing this SpaceX rocket for the first time. The engineers have used dozens, maybe hundreds of different parts and systems, some not even produced by SpaceX, to assemble this awesome vehicle. Everybody put their top game to build the rocket, and now we would like to see if everything works as expected. Launch day is here, and then... yeah, that didn't go as expected. Turns to be you can't just assemble a bunch of parts and test them all together the very first time the rocket is launched. Fortunately, this is not how they usually test a rocket before launching. Without getting too technical about rockets, because I'm definitely not an expert in the area, I just wanted to show here a simplified diagram of the parts of a rocket that I got from the NASA website. All of the different components and systems, like the payload system or the oxidizer, are also individual units of this entire vehicle that all need to operate properly before the rocket can lift off from Earth. And the engineers don't just build these units and send them to the assembly team to put them on a rocket, and after everything is put together, figure out if all the parts work or not. Each part of the rocket is tested in isolation, likely several times, way before being sent to the final assembly into a rocket. This gives certainty to the teams behind each part that as long as it is used according to specifications, that unit will work as expected. And the same goes for the team assembling the entire thing. They know that they can connect all the parts according to specification, and the rocket should fly. This saves time and money for everyone, and likely saves a few lives along the way. So in terms of software engineering, we can define unit testing as a way to test every piece of code in isolation without external dependencies. Now, coming back to our catalog REST API, even with as simple as it is at this point, we do have a few components that talk to each other, like the items controller, our items repository class, the Mongo client instance, and finally the MongoDB database. Each of these components are made of a bunch of methods that represent the behavior that we can get out of them. For instance, the items controller has functions like GetItem, CreateItem, UpdateItem, DeleteItem, and we will certainly keep adding more in the future. These are the different granular units that must individually work correctly to ensure that the whole service provides the expected functionality. Therefore, for each of them, we need to write a series of unit tests that really exercise every aspect and every corner of each of these methods to give us enough confidence on their quality way before trying out the whole service from Postman or from any other client. Beyond this, unit testing has a bunch of benefits that you definitely don't want to miss. With a unit test, you can quickly verify your code without having to worry about dependencies. For instance, you can make sure that your repository class can retrieve items from the database without having to stand up or talk to a database server at all. And such a test can give you results in milliseconds as opposed to seconds or minutes. You can make changes without worrying about introducing regressions. After you have a unit test in place, you can refactor your code as much as needed without concerns of breaking the service, because you know that the unit test will provide you with that safety net. Unit tests will catch bugs at the point where it is easier and cheaper to fix them, which is before merging your code to the codebase and way before getting it deployed to production. Fixing something that is already impacting customers in prod can have an enormous cost, both in human hours and of course in the amount of money lost by anybody that uses our service. And unit tests, if done well, can be the best documentation of your REST API, since every use case should eventually turn into a unit test, and those tests can't lie. They must represent the way that the system works. Now that we know what unit tests are, Let's also talk about test-driven development, or TDD. So what is TDD? Simply put, TDD is a software development approach where you write a test before you write just enough production code to make the failing test pass. This translates into a cycle made of 3 phases. A red phase, where you write a test that represents your software requirement. This test fails because you have not implemented any production code yet. In fact, the test doesn't even compile at this point. A green phase, where you write just enough production code to make the test pass. You don't need to implement anything beyond what's needed to pass the test, and inelegant or ugly code is allowed at this point. Finally, if needed, you refactor the code you just wrote while you keep running the test to make sure that they stay green. It is at this point where you eventually arrive to code optimized for readability and maintainability. You keep repeating this cycle for any new piece of functionality. This is a basic cycle of TDD. Why would you want to embrace TDD? Well, there are a lot of benefits of embracing this practice, but there are 3 aspects I like most. With TDD, you start by focusing on the requirement, not on the implementation. This gives you a lot of freedom in terms of trying to properly address the requirements because you are not constrained by an already implemented piece of code. When you implement the code first, you end up writing tests that verify only as much of the implemented code as you have time or patience for, because you already invested a lot of time and effort in that code. You get increased test coverage because, by definition, you would have not written any more production code other than needed to pass the tests. Again, when you don't do things the TDD way, you might end up with multiple corner cases that you might forget or might not have time to test properly, reducing the test coverage. Finally, clean design is enforced from the start. As you write the test, you will naturally start designing the pieces of the production code in such a way that leads to a passing test. The classes and methods emerge from the test, and you naturally avoid the pitfalls of writing code too coupled to be tested. There are 3 main unit testing frameworks in the .NET ecosystem these days: NUnit, MSTest, and xUnit. They all fulfill the same purpose of allowing you to write and run your unit tests in an automated way. However, for any new project, I strongly recommend you choose xUnit. This framework comes from one of the original authors of the popular NUnit framework, but it was written to be more closely in line with the .NET platform and to help write clearer tests. It is also more intuitive than MSTest, which requires more attributes in test classes, some of them not straightforward to use properly, especially for developers new to the platform. Let's see now how to implement unit testing and TDD in practice. It's time to add a new test project for our unit tests. But before we can do that, I think we should restructure things a bit to give our REST API a more specific directory that will live side by side next to our upcoming test project. So I'll start by going to our Explorer view on the left side, and I'll just look for an empty section over here, and I right click and I'll say new folder. The new folder is going to be catalog.api. And now let's move most of the directories and files over there except for .vs Code, bin, catalog API, and obj. So let's grab everything else into catalog API, move, and now that has all the files for the catalog REST API. Now let's close this, and then let's delete this directory. We don't need this bin directory or this obj directory. Those are gone. Now just to match the folder name, let's rename the project name into catalog.api. And then we'll have to make a bunch of renames across a bunch of files just to match this new project file name. So I'll copy this name here, close this, and then I'll go to search and replace. And we're going to replace catalog.csproc into catalog.api csproc. So let's just replace all. Then we'll do the same thing with the DLL. So catalog.dll, it's the output DLL. It's going to be renamed into catalog.api.dll. Let's replace these, all the files. Now let's look at the namespace. So today we have this namespace catalog, and that should turn into namespace catalog.api. And then for every of the classes that are using that namespace, let's make sure they use the new namespace. So using catalog, should turn into using catalog.api. Let's do that replacement. Now let's look at our let's see, a VS Code .json file where we have this workspace folder / catalog API. It's time to change that. So replace this with / catalog.api / I'll do just in this file, replace all the entries. It's all done. And now let's go to launch.json and do a very similar replacement. So workspace folder into catalog.api, workspace folder / catalog API, replace all in this file. And I think that's all we have to do. So I'll just close this too, and then I'll do Ctrl+Shift+B to make sure everything is built in properly. Yeah, looks like it is. I'll close this, I'll run this one here just so that NuGet packages are restored, but everything looks fine. So I'll close terminal. Now, among the things that we modified, and I'll collapse this one, is the Docker file. So the Docker file is now pointing to catalog API.csproc. So I just want to make sure that this is still building properly. So I'll rebuild our Docker image now. So I'll open my terminal. Let's open a brand new PowerShell terminal. And given this new directory structure, I'll have to go into catalog.api. And here I can run my docker build command again. So I'll just do docker build -t. And then it's going to be Julio C / catalog b3 and dot. Okay, so b3 because we were creating a new version of this Docker image, which was b2 last time. Hit enter. Okay, so the new image is created. I'll do Docker images. So yeah, it's right there. The image was created, so everything looks just fine. So this is great. I'll close terminal and I'll close this file. So now we can actually create our test project. So I will collapse this for a moment. So we want to create a new test project just at the same level. So I'll go back to the terminal actually, and we're going to go up one directory. And to create a test project, you do it actually very similarly to as how you do for the creation of the web API. So you just use a .NET CLI. So .NET new. And like I said before, the preferred test framework for test project is xUnit. So I will go for xUnit. And let's name this project catalog.unittests. Okay, hit enter. And our unit test project has been created. So it's this one over here. It has a project file and an initial class, test project class over there. Now, one interesting thing that we have now here is that we need to build not one, but two projects, right? And so anytime we want to make sure that everything is building properly. However, our VS Code environment has not been configured for that yet. So if you look at task.json, and I'll close this, it is configured to build only the catalog API csproc. So how can we make it so that anytime we build, it builds both projects? So there's a handy way to do this that I'll show you. And what I'll do is I'll create a new file at the root here, just at the root. That's going to be named, we will call it just build.proj. Okay, and then I'll collapse this for a moment. And this file is going to allow us to build all the projects in one shot. So how do you do that? So let's declare the following. So you will do project SDK. And here we're going to be using the build traversal SDK. So to do that, you just type here microsoft.build.traversal. And then you specify a version. So because this is actually going to pull a NuGet package down into your machine. The last version that I found last time was 3.03. So I'll do that. Okay, let's go ahead and also close this. And inside this section, you have to specify an item group. So item group. Now close that item group. And here you have to reference all the project files that you want to compile. So for that, you want to type project reference include equals, and then we'll just do this expression. So everything, so star.star.proc. So any files that end in proc are going to be compiled by this file. Okay. So with this file ready, let's go back to Explorer. Let's actually go ahead and into task.json, and let's ask it to no longer just build catalog API csprog, but instead it's going to build build.proj. All right, so with that done, I'll do Ctrl+Shift+B. Yep, and now let's close this, let's close that. You can see that both, let me just do this for a moment, catalog.api DLL and catalog unit test DLL have been built by this one command. So notice that you don't need a Visual Studio solution for this at all. This is my preferred way of building like all the projects in a solution. So build.proj, just include all the project files, and that will do the trick. Right, so I'll close these two now. And then our test project here will need, of course, a reference to our API, because we're going to be testing the API controller. So let's make sure we have that reference. So open terminal again. I'll switch to my PowerShell terminal. And then let's see, I'll go into catalog.api, sorry, catalog.unit tests. And then I'll do .NET add reference. And then we're going to go into catalog.api, catalog.api.csprog. Right, so that adds the reference. If you look at unit tests, close this, it will have that project reference right here. Okay, so now the test project can use any of the files or reference any of the files in the API project. Close that. And then we're going to need a couple of additional NuGet packages in this test project. Let's actually open this again. And these are going to be, first we're going to need the NuGet package for extensions login abstractions. So let's do that. .NET add package, Microsoft.extensions.login.abstractions. And this is because we are going to be using or trying to test our controller class, which if you look at it quickly, the controller class does receive a logger in constructor over here. So we're going to be needing to use this iLogger class, and for that we need that NuGet package that we just added. The other package is .NET add package. It's called mock, M-O-Q, and this is a little framework that can help you actually mock your classes, the classes you're using in your controller, so that you can test only the pieces that you care about in controller, but you don't have to worry about how to create or how the dependent or external dependencies of that class work. And we're going to go into those details in a moment. But yeah, those are the two NuGet packages that we need for now. So I'll close terminal again. And then let's start focusing on our test class. In this case, unit test 1. Let's rename this class into a more appropriate name. So rename this into items controller tests, right? So the convention that we're following here is that if the controller is named items controller, that's a class name. We're going to be using the class name with the suffix of tests for test class. So items controller tests, that's the one that we have here. And that's the one that we're going to use for the class over here, items controller tests. I'm going to collapse this navigation pane now. I'll do Ctrl+Shift+B, make sure everything is building properly. And then if you happen to be getting any of these red squiggles here, which it should not be there, but if it happens, let me just close this. What you can do is just do Ctrl+Shift+B and do OmniSharp, restart OmniSharp, or you can type that there, OmniSharp, restart OmniSharp, and that should take care of that. Now, notice this fact attribute that was added to our auto-generated test1 method here. So fact is the attribute that you have to use to declare that one of the methods in this class is actually a test method. So that's the only way for the test runner to recognize that it has to execute this test. So just don't forget to add fact to each of your test methods. There are other ways to declare or to decorate your methods as test methods, but for this tutorial, we'll stick with fact. So now let's go ahead and start writing our first unit test. But before that, let's look again at our items controller class, and let's see what should be unit tested. We will write unit tests for all of our methods over here, but let's start with GetItemAsync, just because there's a couple of simple and nice cases that we can go across this method. In fact, as for receiving an ID, as you remember, we will be able, and we will try to find the item in the repository. And if we cannot find it, if it is null, we will return not found. Otherwise, we will go ahead and convert the item into a DTO. So let's write a couple of unit tests to verify this method. So going back to our test class, one thing that I'd like to encourage you is to use a good naming convention for the unit test. This is very important because it really helps to identify what is this test supposed to do, what is it really verifying, without having to go into all the details about the unit test. So one good naming convention that I like is the following. You want to use 3 parts here. That's going to be unit of work, state under test, and expected behavior. Right? So first part, unit of work. So what is that you're testing? What is the function that is going to be tested by this unit test? That's unit of work. Then state under test. So under which conditions are you testing this test method, right? And then finally, the expected behavior. So what do we expect from this unit as we execute this test, after we execute the action part of this test? So now translating that into our GetItemsAsync method, let me just copy the name here. The unit of work is in fact the name of the test method, so GetItemAsync. And the first case that I'm going to test is what happens when we cannot find the item. So the item is null, right? This section here. So for that case, I'm going to say with an existing item. So the item does not exist. What will be the expected behavior then? It's returns not found. Okay, so that should be a good name for our unit test, our first unit test. Now, within the body of your unit test, there's also another good convention that encourages us to write the test in this way. So there's going to be 3 sections here. The first one is called arrange. Second one is called act, and the last one is called assert. This is also named as AAA, arrange, act, assert. And the idea is that you're going to first have an arrange section where you're going to pretty much set up everything to be ready to execute the test. So just before executing the test. So this includes any sort of mocks, variables, any inputs that you're going to need before executing the test. Then we go to the act section where we actually execute the test. We perform the one action that we are testing here. And finally, the assert section where we verify whatever needs to be verified about the execution of the action of the unit. Okay, so how does that translate into our unit test? So we want to test items controller. And for that, we'll have to, of course, create an instance of items controller. However, remember that we need 2 parameters here. So we need a repository and we need a logger. Now, one thing to remember here is that for the purpose of testing this unit, this GetItemAsync method, we don't really care about the internals of how the repository, for instance, the repository behaves. So we don't care what happens normally when you call GetItemAsync. As you know, that will go ahead and talk to the database, retrieve the item, and all those things. But we don't want to test that. We don't want to test a repository. We just want to test the GetItemAsync method. This is the one unit that we want to test. So you have to make sure that you find a way to exclude those dependencies, the behavior of the dependencies from this test, and just focus on testing what's right here. So to do that, of course, we cannot use a real item repository or a real logger. And here's where we have to introduce what we call stubs. And so a stub is going to be a kind of a fake instance or a fake version of these items, of these classes that are going to be used just for the purposes of the test. So let me show you how that looks like. So in this case, I'm going to say, so we need a repository, right? So I'll say repository stub equals new mock, And then mock it comes from the mock library that we installed a moment ago using mock. So this is a library that allows us to mock any of the mock or stop any of the different dependencies of our class. So luckily, our controller, as we looked at the previous videos, we made it in such a way that we can do dependency injection in there. So the controller really doesn't know what kind of repository is coming in here or what kind of logger comes here. It's just looking at interfaces, as you can see. So that gives us a flexibility to fake these both dependencies from the unit test. So I'll go ahead and say, okay, so this is going to be a new mock of items repository. Okay, let's see if I'm missing a namespace. Notice that I'm naming this as a stop and not as a mock. And that's a slight difference that I like to make because when you do stops, you will not verify anything on this object itself. When you do mocks, you will, in the assert section, you would go ahead and actually verify something that happened to the mock across a test. So it's a slight difference, but it's good to do the proper naming here so that you understand what is the purpose of the variable that you're using. Okay, so now the expectation is that when we call, let's go back to controller. When we're going back to our method, when we call the GetItemAsync method, the idea is that it will return a null. And so when it returns null, the controller should return not found. So we need to set up that scenario. So how do we set up this method in the mock so that it returns null? Going back here, what you can do is this. Repository stop dot setup. And then you're going to say, let's say repo.getItemAsync, and then comes a parameter. Now, at this point, it really doesn't matter what's the item that we are going to be passing in here. It's irrelevant because what we want to evaluate is what happens with the return value. So because of that, what you can do is just say it is any, which is a function provided by mock also, any GUID. This means whichever value comes in, it doesn't matter. So mock will take care of providing some value in there. And then that will do, it should return a value of null. That's what we want. That's the expected behavior. And then, just so that mock doesn't get confused, we have to cast this into the item entity. And let me add a proper namespace right there. Okay, so this is setting up the scenario for our test. So we're saying, again, whenever the controller invokes GetItemAsync with any GUID, which mock is going to provide, you have to return a null value. That's what we need for this case. And then similarly, we'll do something with the logger. So we'll say logger stop equals new mock. I'll say ilogger of items controller. Okay, let's see if we're missing something again. Yep, missing that. We're missing the controller's namespace. Okay, so now we have two stops ready to go. And now we need to create the actual controller. So now we can say controller equals new items controller. And then we pass the stops. So repository stop, but we need to get actually the object property of this because that's the real object that's going to be passed in, not just the mocked object. And then logger stop that object. So that covers the arrange phase of this unit test. For the act phase, here's where we execute the action. And this is normally just one line where you execute what you're going to be testing. So I'll just say result equals await. And yeah, now that I'm using await, let me remember that we have to use a proper return time for this unit test. Since we're going to be calling an async function, this test should actually switch to be an async task. Let's see, yeah, adding that. So now we can do await controller.getItemAsync. And then, like I said, it doesn't matter with what GUID we provide here. So I'll just say GUID, new GUID. And that's the action. And then finally, we'll go ahead and do the assert. So with xUnit, you have a bunch of assert methods available. So let's just use assert. And then what we want to verify here is that what we got was indeed a not found. And the not found, there's a class that represents not found. So what we can say is assert that is type not found result. And then let's see if we're missing something. Yeah, let's add that. And then what we're going to pass here is result.result. So the result object, the result variable represents the action result that we received. And the result property inside that result represents the actual type of result that we got, which in our case, it should be not found result. And now that we have that, we can go ahead and actually execute the test. And so there's a bunch of ways to actually run this test in VS Code. One of the ways that I use frequently is by using the code lens. As you can see over here, there's this set of annotations, which is introduced by Kotlin, Visual Studio Code Kotlin. And what you have to do is just click on Run Test, and that should go ahead and run the test. So let's see what happens. It's a running test, and the test has passed. As you can see, the one test that we have passed, which is good. Now there's another way to run the tests by using directly the .NET CLI. So if you go to terminal, I'll switch to here. Make sure that you are in the catalog unit tests directory. And here what you can do is just do .NET test. Yeah, so that will go ahead and run not just one test, but all the tests that you have across the test project. So this becomes more handy when you just start having more and more tests for this test project. And as you can see, yeah, it passed. 0 failed, 1 passed. Now, as the number of tests increases, you may want to have a better way to visualize the overall status of your test suite, which cases are passing, which ones are failing, and so on and so. So to do that, there's actually a nice Visual Studio Code extension that you can install to provide that visualization. So let's go to our extensions hub, and let's expand this a bit, and let's look for .NET Core Test Explorer. Just the first one here. I'll collapse this for a moment. .NET Core Test Explorer by Jun Han is the best one that I found so far for this kind of tests. So I'll go ahead and install it. And what you need to do about this extension is to tell it where to find the test project. And if we go to Explorer for a moment, you'll remember that we have our tests in this catalog.unit test folder, catalog.unit test CSproc. So we need to provide that location to this extension. To do that, you can click in this gear icon over here. Just click on that, extension settings. And if by any chance these settings that you see over here are not showing up for you, what you can try is just closing Visual Studio Code or closing the current folder and reopening it, and then these things should show up. It may happen the very, very first time, but after that, it should be just fine. Then what you want to do is go all the way down where it says .NET Test Explorer, Test Project Path. This is where we need to specify the path to the test project. But also, you want to go not into the user section, but into the workspace section. By doing that, what you're going to type in here is going to live alongside your project, as opposed to in some place in your user profile. So that's good, so that you can keep everything together. So here what we want to specify is just a simple expression. So let me type that. So it's a glob pattern where we're going to say just search all over the place inside of our catalog directory and in all subdirectories, and then look for tests.csproc. Okay, and after doing that, we can close this. And if we go to these 3 dots here, there's now a test section. And as you can see, there's our one test is already showing up over there. And then to run it, you can either click this play icon here, or you can just click the play icon on the top, and it will go ahead and run all the tests that are available there. So as expected, it is green. And you can see the green mark also on top of the test. And if there was any error, that you will get some red squiggles in the location where the test failed. So yeah, so we'll be using this extension across this video to see the status of our tests as we are adding them and executing them. Okay, so now that we have that in place and that we have a test for checking for the unexisting item case, let's add another test for the existing item. So what happens when the item actually exists? So let me actually collapse this for a moment. So I'll do hide sidebar. And let's add a second test here. Perhaps I'll just copy the header of this test. So I'll copy that over here. Here's a new test method. And this one is going to be called GetItemAsync with existing item returns expected item. Okay, and just like before, we will do the AAA arrange, act, and assert. Now for this test, it is very likely that we're going to need, again, our repository and our logger stub, both stubs. So instead of copying the instantiation over here, why not just declare a couple of class level fields, and that way we can reuse them in this test and in any future test. So let me do that. So I'll go here. So I'll declare private read only. Going to be mock of items repository. Then I'll just copy this piece here. Although I could just do this, and then private read only mock of logger of items controller, and then it will be the logger stub. We can just do this. And with that, we can go to our initial test case and just simplify a little bit by not having to declare it here, declare the stop there or the stop here. Okay, and so going back to the new test case, for this test case, we will actually need to have an item that we can use across a test. Because let's go back to the controller quickly, items controller, hide this. And if you remember GetItemAsync, in the case that we want to hit, which is the one that returns the DTO, we need to have an item. We need to have the repository, get and return an item, and then we need to convert it as DTO and return it. So to do that, we'll have to set up that item beforehand in our test so that it can be used over here. So I'll go back to the test, and instead of just creating it on the fly for this test case, I'm thinking that we should have some sort of helper function that we can use not just in this test, but instead of future tests to create some random item very quickly. So I'm going to go ahead and create a private function. So private item is going to return an item. Let's call it create random item. And this is going to say just return new. And let's specify all the properties for the new item. So it will be ID. Let's make it GUID.new GUID because we don't really care what ID it uses. The same way we don't really care what name this random item uses. It should work with any name. So new GUID to string. And then for the price, what we want to do is probably just generate some random number so that we don't get fixed into any specific price. So for that, what I'll do is I'll actually create a random variable, and let's put it at the top over here. So I'm going to declare private read only random, and let's name it just rand. It's going to be new. So this we'll be able to use in a couple of places. So now we can go back here and we can say rand.next. And then I think we said that the price should be between 1 and 1,000. And so let's just set a maximum value of 1,000. Should be enough. And created date is going to be datetime of set.utc now. Okay, so now that we have this handy method, let's go back to our test case over here. And in terms of arrangement, what we have to do is first prepare the item that that the repository is going to return. So we're going to say var expected item is create random item. Then we have to do the setup for the repository. And that's going to be a little bit similar to what we did in the previous test. So I'm going to copy this first line from the previous test. There. So when we call GetItemAsync, again with any GUID, what we want to do now is return that item. So returns async expected item. Okay, and then we'll go ahead and do pretty much the same thing that we did in the previous test. So copy this couple of lines over here. So we declare the controller with the two stubs, and then we get a result, right? By invoking GetItemAsync with any GUID, it doesn't matter. And then it is time to assert what we got. So what we would like to assert here? So probably we want to first make sure that we got the actual DTO and not some other result like not found or bad request or something like that. So I'll do assert that is type item DTO. And let's add any missing namespace. And then we're looking at result.value because it is the value property, the one that actually should have the DTO in this case. Okay, and when we have asserted that, what we can also do is, what we should do is verify that all the properties of the return DTO match the expected item. So for that, let's first take out that DTO. So we can do that by doing some casting here. Result as action result of item DTO, that value. And then we can do assert dot equal expected item dot ID should equals DTO dot ID. And just like that, we would need to go through every single property, right? So expected item ID, now expected item dot name should equal DTO dot name. And well, we'll keep going and going with the other properties, but at this point, imagine that you don't have just a couple of properties, but you have dozens of properties, right? As objects can get complex. So this is going to become very cumbersome to just keep asserting. And in fact, it's not a very good practice to be asserting too many things in this case. You should try to assert or get close to assert just one thing in each test. That's kind of the best practice. And so to do that, what we can do is instead of doing all this, we can switch to a very handy assertion library that's called FluentAssertions. And that one will allow us to do this in a much more straightforward way. So let's bring in the terminal. I'll do Ctrl-J. And I'll go to PowerShell. And here's what I'm going to do. So make sure that you are in the catalog.unit tests directory. And then you can do .NET add package FluentAssertions. Okay, so with that, I'll just close terminal. So now we can do something a little bit different. So let me show you. What we can do is now we can say result that value, and then should, and then let's import the FluentAssertions namespace, be equivalent to the expected item. Okay, and then I'll remove this. What this is expected to do is that it should compare the values of the properties of the resulting DTO with the properties of the expected item, the item that we created over here, right? So that way, with this very handy method, we don't have to go property by property. It will just go ahead and compare the entire thing for us. But then the only issue here is that since expected item is actually a record type, as you remember, the item is a record type. Record types already override the equals method of the object, and that will make it so that this method doesn't behave very well, right? Because it believes that it has to compare the DTO to the entity directly as opposed to comparing the properties, which is what we care about. So to address this, we'll specify an additional option here, which is going to be options dot comparing by members of the item class. With that, we are saying, hey, don't compare the DTO directly to the item. Just focus on the properties that each of them have, and as long as the property is the same name, compare the values of those properties. So that way, it will go ahead and it should go ahead and tell us that the objects are the same. Yep. And so with that, let's go ahead and run this test case and see what we get. So we'll go ahead and click Run Test. Yep. and the test case is passing. And just like we did this, just to keep things consistent, let's also modify the previous test to also use FluentAssertions. So in this case, this is going to be result.result should be of type not found result. Yep, that replaces the previous line. Okay, so let's just verify that all test cases are passing. I'll go ahead and run this in the Test Explorer here. And yes, it's all looking good. Okay, and so now let's move ahead into our next unit test. So let's go back to the controller briefly, and let's see what else we got there. Collapse this. And back in the controller, what we want to test now is our first method here, the one that returns all the items available in the REST API, in the repository. So remember, this item will just go ahead, retrieves all the items, transforms them into DTO, and then it returns them. That's all it does. So what we want to verify is that for any of the items that we set up for this repository, that we have to set up with the repository, they have to be returned as DTOs, and they should match exactly the items that will obtain from the repository. So let's go ahead and write a unit test for that. So back into the test class, again, I'm going to copy the header of this test case, and I'm going to scroll down here, copy that. Okay. And so here, let's do the proper naming. So this is going to be named GetItemsAsync, and this is going to be yes, with existing items. It will say returns all items. And again, let's bring in our arrange, act, and assert sections. And in this case, what we need is, of course, to get a series of items from the repository. So what we have to do first is to declare such a set of items, and for that we will create a simple array. So what I'll do is I'll say var expected items equals new, and this is going to be an array, and we're going to be using our createRandomItem method here a few times. Perhaps let's bring in 3 items. Yep, so that will do it. Very handy method. And now we can go ahead and set up the repository to return those items. So I'll do repository stub setup with repo.getItemsAsync. So when getItemsAsync is invoked, it should return the expected items. And then we have to construct the controller. So I'll do it very similar to what we did with the previous test case. So I'll just go ahead and copy this line over here. And then we will go ahead and do, so var actual items equals await controller.getItemsAsync. Okay, so that should retrieve the items, and now we have to do the comparison. So once again, we can use that very handy method of FluentAssertions to do just an equivalence of comparison. So we can say actual items should be equivalent to expected items. And once again, we'll have to do the options because we're again, we're dealing with record types. So otherwise things will not work right. And then options that comparing by members item. Okay. Okay. So with that, let's go ahead and run this test. Let's see what we get. Yep. Test passing. Awesome. Close that. Okay, now let's move forward back to items controller. It's time to test our CreateItemAsync method. So this is the one that goes ahead and creates the item in the repository. So in this case, we have to provide an createItem DTO as an input. And then what we can verify is that we should be receiving as a return a DTO with the created item. That's what this method is supposed to do. And in fact, that returned item should include the ID, because the ID is not provided in the createItem DTO. So the returned item will have an ID, and it will also have a created date. So let's write a test that can verify all these things. So back to items controller tests. Let me again grab the header of the test. Perhaps I'll grab the entire thing. Just copy this, and then remove this piece, and remove this piece, and I'll remove this other piece. Okay, now this method will be called, just starts with the name of the method, which is CreateItemAsync. And then this will be, in this case, the current state, let's name it with item to create, because we're going to be providing the item that should be created. And then the expectation is that it returns the created item, right? Now, in this case, the arrange piece involves preparing the createItem DTO. So in this case, it will be tricky to try to use the created random item as we've been doing so far. So we will be explicit in this case. So we will say item to create equals new create item DTO. And here we'll provide the elements of the created DTO. So we need to provide a name, which is just going to be GUID, new GUID, string. We will provide a price, which again is going to be just run.next with 1000 again. And I think that will be it. So let me go quickly to create identity. I'll do F12 to make sure I've covered the properties that we need. So yes, the name and the price. Yep, back here. Yep. And then in this case, I will actually not need to set up anything in the repository because it is not interesting what happens. I mean, for the terms of this test case, it is not interesting to see what happens when the repository is invoked, if the repository is invoked to create the item. So if you look back at items controller, what's really going to happen here is that, repository needs to call CreateItemAsync, and that will go ahead and create the item. But I would encourage you to be a bit careful about what you're going to be testing here, because you could also decide that, no, I want to make sure that the CreateItemAsync method is called in the repository, right? So that I mean, it should get created. But that's going a little bit too much into the details of the test case. So you will be making your test case very prone to needs changes in the case that the implementation of this method changes, right? So ideally, you want to treat each of your test cases in such a way that they only provide some inputs to the method, and then eventually they validate the outputs of the method. But they don't try to make assumptions of what is going to happen inside. So in this case, we are not going to be caring about this method at all. So in fact, we're not going to be setting it up, and we will go ahead and back to the test case. We'll go ahead and just invoke the action. So we will say var created item. Sorry, it's going to be var result equals await controller dot CreateItemAsync. We provide the item to create, and then we can go ahead and do the assert. And the first thing we're going to do here is try to retrieve that item DTO. So what I'll do is I'll do created item is the result as created at action result. Okay, that's a type of result we're going to receive here, is a created at action result. And from that one, we want to get the value, and that value will turn it into an item DTO. A little bit convoluted for this case. And now we can do the same equivalence thing that we've been doing so far. So item to create should be equivalent to created item. Okay, and then we provide options. Like we said, it will be options that comparing by members. And in this case, the type that we want to use here is actually item DTO. Okay, which is the type of the object that we received from the test of the created item. Okay, but additionally, we want to do one more thing here, because both of these DTOs don't have the same members. If you remember, if we go to F12 to item DTO, this one has 4 properties, as you can see. But if we go into CreateItem DTO, this one has only 2 properties over here. So that means that if you try to compare things like this, it's going to fail because it's going to say, hey, one of your items has more properties than the other. So this doesn't make sense. So in these cases, what you can do is say, only look at the properties that are common between the 2 objects. And that will simplify things in this case. So that's something we can do. And then in the spirit of FluentAssertions, we can just do dot excluding missing members. Yep. And that should do it for that one assertion. Okay, so we're comparing that the 2 objects are equivalent, but we will not pay attention to any members that are missing from any other. However, we may want to actually check for those additional members. So for those ones, we will be a bit more explicit. So created item, the ID should not be empty because the method, it should generate an ID for this created item. And also created item that created date should we don't know exactly what day we're going to get in there, but we know that it should be close to the current time, right? Because this test just takes milliseconds to execute. So we will say datetime of set UTC now, and then just to be safe, we're going to give it a range of precision because we don't know exactly how much time the test is going to take, although it should be super fast. But we're going to give it 1000 milliseconds to for the difference between the times of when the item is created and the time that we're checking here. Okay, so that should be it for this test. So let's go ahead and run it, run the test, see what we get. Yep, so test is passing. It's looking good. Okay, so the next test that we're going to look at, but the next case we're going to look at is the case of the UpdateItemAsync. So as you remember, this method gets the item to update. It will get it from the database, and if it doesn't find it, it will say not found. And then otherwise, it will create a copy of the item to become the updated item with the updated properties. And then it will go ahead and update the item in the database, and finally returns no content. Okay. Just to not spend too much time here, we're only going to be covering one case here, which is the case of where the item actually exists. But you can imagine how to test for the not found case, which is a bit simpler. But then again, don't get into the trap of verifying that the item is actually being sent to the UpdateItemAsync method of the repository. We will provide an input, which is these 2 parameters here, and we expect the output of no content at the end. That's everything that we need to verify here, nothing else. We don't need to worry about the implementation of the method. So let's go back to items controller test, and let's bring in, again, I'll do a copy of our last test over here. And so this is going to be UpdateItemAsync with existing item returns no content. Okay, and then we don't need this. We probably need the controller. We don't need that, and we'll also remove these pieces at the end. Okay, so for the arrange piece, as you remember from items controller, we will need when GetItemAsync is invoked, it needs to return an item, right? So that we can move forward in the test case. So I think that situation we covered already somewhere else. So let me go back a little bit up. Yep. So this one here. So we will grab this from the GetItemAsync test case. Let me grab that here. So that would allow us to have an item being returned by the repository stub. So we will name this one existing item. That's the item that exists in there. And now we need to declare the actual item that we're going to provide to the method. So the updated item. Yeah. So let's first grab the item ID as a variable. So the item ID is existing item.id. So we'll grab that there. And then item to update is a new update item DTO. And so we're going to provide a name. So name is going to be GUID, new GUID to string, and perhaps do it in another line. And then for the price, what we can do is just take the price of the existing item, the price, and just increase it by some value, let's say by 3. Okay, so that becomes the update that we perform this item. So we pretty much, we are changing the name because we're generating a new GUID, and we're changing the price by adding 3 to it. Then we create the controller, and now it's time to do the action. So we'll say result equals await controller.updateItemAsync, and then here's where we provide the item ID, and then we provide the item to update. And then finally we go for the assertion. Then this assertion is going to be very simple because, like I said, we only want to verify that we get no content. So result should be of type no content result. That's all it is. So again, we set up the return of the item from the repository. We prepare an item to update. We modify the properties. We invoke UpdateItemAsync. And at the end, if everything went well, we should be getting a no content result. So let's go ahead and run this test. All passed. So I think we're missing just one method at this point. Let's go to items controller. So this is DeleteItemAsync, right? It's going to be very simple actually to verify and very similar to update. We get an ID. It will have to find the item. Again, we're not going to check all the cases for this case, just the case where the item exists. So we'll make it so that it returns the item, and then it should return no content. And again, we don't care what happens with the repository or any of the internals here. We just care about the fact that it should return no content. So back to items controller tests. I'm going to copy our last test case once again. And this is going to be named DeleteItemAsync with existing item returns no content. Yeah, that's an appropriate name. This setup will work just fine for this case. But then we don't have to prepare any item to update. Just do that. Create the controller with those setups. And then we'll do DeleteItemAsync with the, it will be just the existing item.id. And then the assert is exactly the same as before. The result should be of type no content result. That's all it is. So I'll go ahead and run this test now. And yep, it is passing. And in fact, if we go to our Test Explorer now, let's go to the test section here and let's run this. And as you can see, we have a full suite of tests passing at this point. Okay, so this is great. We have a bunch of test cases covering many of the scenarios in our controller. And what this gives us now is actually a lot of confidence on making any future changes across the REST API. So what I'd like to do now is there's been a few changes that I wanted to make across the board, but I didn't have a way to make sure that I didn't break anything. But now we do. So I'm going to make two radical changes here. One of them is that I'm going to switch our entity to not be a record type anymore. So remember here, if you go to the entities item, so the fact that it's a record type is actually making things a bit inflexible. I mean, because of this, we cannot just update existing items in the update operation in the controller, and we have to create this copy that's not really needed. So this entity should actually be mutable, so we don't need this init stuff here really. So we'll switch this to be a normal class, and we will also add a description property here so that we can provide some description for the items. So let's make those two changes and let's see if our test cases can help us prevent breaking anything. So like I said, this item is going to change from record to class. And then we will not be using init here, but we will switch it to just set. So set in all of this. And now this is a normal standard class. And also, like I said, we're going to be adding a description for the entity. So with that done, the other thing that I like to do actually is to simplify the way that we use DTOs. Remember that we have these 3 files for the 3 DTOs. But it turns to be that there's a much better, nicer way to declare the DTOs as record types, which actually provides even more benefits that we are doing today. So what I'll do is I'll actually just get rid of all these files. Let me just delete this DTOs folder, perhaps collapse this a bit. And what I'm going to do is create a new file at the root of catalog API. Let's name it DTOs.cs. Okay. Let's bring in some namespace, the right namespace, which is going to be catalog.api.dtos. We will declare all the DTOs here inline in a much more nicer way. So let me hide the sidebar. So for the first DTO, it's going to be the item DTO. So we will say fully record item DTO, and then we will declare the properties as if we were creating like a constructor for this property. That's something that you can do. So we will say GetID, and then let's see if we're missing using system, and then we'll do name, the new description property, the price, and the date time offset created date. Okay, so that's enough. That's what you need to do to declare a record type in this other syntax. So as you can see, it's much more simplified. Now let's declare the next one. It's going to be public record create item DTO, and then this is going to have no ID but the name, and then the new description property, and then the price. But let's not forget that we had set up some attributes here to make sure that we get valid inputs. So in the case of name, we want it to be required. Let's add a missing namespace. And in the case of price, what we want is to verify a range. So the range, yeah, it was from 1 to 1000. Okay, we will not require description, and we will not add the required attribute to price, because price is actually a value type, so it cannot ever be null. You will get some value there anyways, and we will just verify that the range is correct. Lastly, let's add our last DTO that we're missing. I just copy that one, and this is going to be UpdateItem DTO. Yeah, so that's all we need. So now in one file, we are declaring all the DTOs that we're using across the REST API, as opposed to 3 files. Let's see what else we need to modify. So now that we make those changes, let's look at extensions. Let's see what's going on here. Yeah, so I'll hide sidebar. So now that we changed the way that we declare our DTOs as record types, they have become immutable. We cannot go through this initialization anymore. We must create the DTO via the constructor. It's the only way to create instances of them from here on, and after construction, nobody can change the properties of the DTO. So we will say new item DTO, and then we will provide item.id, item.name, item.description, item.price, and item.createDate. All right. That's all it is. Yeah, we could inline this over here, but it may be too much to read. So we'll just leave it like this. Okay, let's see what else we have to fix. If we go back, so there's something going on in the controller. Let's see what it is. Yep, so there's an issue with UpdateItemAsync. Yeah, so we cannot use this syntax anymore because the item is no longer a record type. Now it is a standard class. And in fact, this is good. This is actually exactly what I wanted to fix here, because there's no need to create this updated item. We could just modify the existing item. So we will say existing item dot name equals item DTO dot name, and existing item dot price equals item DTO dot price. Yep, so we don't need this additional guy here. Yeah, We'll leave it like that. And then for the update, we'll just invoke existing item. Okay, so yeah, there's no more breaks around here. Let's see what else. So in the catalog API, everything looks good. In the unit tests, let's see what's going on. Okay, let's hide the sidebar. Let's see. Yep. So create item DTO has to be, we need to specify the properties inside the constructor. So we'll have to provide this for the name. And then probably we'll do the same thing for the description. And for the price, the random number. Perhaps, so I'll delete this, and then I'll do it like this so that it is easier to see. There. Okay. So let's see what else we have to fix here. Yeah, same case for update item DTO. So let me copy this line here. So we have to provide that. Then we provide a description. And then we provide the price, which is going to be existing item price plus 3. Okay, remove this. Yep. And with that, I think we don't have any more breaks or nothing that I can see actually. And so let's go ahead and let's run our tests and see what we get. So I'll go ahead and run the tests. Yep. And interestingly, we do have something failing here. Let's see what's going on. So CreateItemAsync is the one that's failing. And as you can see, we're getting the X over here, signaling that there's a problem. We get the squiggles here, signaling that there's something in there. And if we see the message over there, you can see it says expected member description to be null, but found some value in there. Yep. And then, so what could have happened? So let's actually go back to our controller. So I'll do F12 from item controller. And let's go to the create method over here. Let's hide this, hide sidebar. And yeah, so what happens here is, if you can spot that, is that we have not presented a value for the description. So let me actually close this, close that, and this. So back to the test. Yep. So when we declared the item to create, we did add a description, but when we created the created item does not have any value for description. And that is because we have not specified that here anywhere. So that's something we have to fix. And that's a nice thing about using this should be equivalent to, because as you add more properties, you don't have to be remembering to do the proper checks in the test cases, right? Otherwise, anytime you add a new property here, you have to go back to the test and add the properties in there to make sure that you don't forget. But with this, the test case is actually covering you, making sure that you don't forget to add those properties in the place where you're implementing the method. So in this case, I'll do description equals item DTO dot description. And with that, let's go back to our test list and let's just run them again. And it's all green now. And then one minor improvement that you can also do here is to change the way that we're doing some comparisons across a few test cases. So if you go back to this test case, GetItemAsync, with existing item returns expected item. If you see how we're doing be equivalent to here, these options, we needed to do them because the item class, it was actually a record type before. So that was causing issues. Now that it's not a record type, we can stick to the normal behavior. So now we can just remove this and do the equivalent to this way. And FluentAssertions will know what to do because this is just a standard class. The same way, we can go to the next test case and change this thing, and that should be enough. And this is only because, like I said, because what we are comparing here is standard classes and not record types. So with record types, you still have to do the other way. So let's just make sure that the test cases are still passing. So I'll go ahead and run all the tests. And everything is still all green. Okay, so that's working pretty well. And now I'd like to switch gears into test-driven development, TDD. So we talked about TDD. It has some very nice benefits because it allows you to start from the test, from the requirements really, and then move forward to implementation later on. So let's see how TDD works in practice. And what we're going to do is, if we go back to items controller, and I'll hide this for a moment again. Let's go back to our first method here, GetItemsAsync. So as you see, this is the method that returns all the items. But a new requirement to our REST API is that we should be able to return the items by the name. So if somebody specifies a name into such a method, we should be able to return only the items where the name contains the specified parameter, right? So if we have items that have, for instance, the word potion in them, like high potion, mega potion, all these things, we should be able to return all the items that include potion in the name and not the other items. So it's a way of filtering things. So let's see how we can go ahead and implement such a method by using TDD. So I'll go back to items controller tests. Yep. So let's grab this method, GetItemsAsync, and then I'll just copy that just under it because there's similar methods. But in this case, we'll rename it to GetItemsAsync. We will say with matching items returns matching items. Okay. So in this case, we're going to go ahead and we will not be using the random item anymore because I actually want to specify a name for our items. And in fact, that's the only thing that we care about in the case of this test case. I want to be more explicit here. So what I'm going to do is rearrange this a little bit so that instead of this, what we have is, let's name this all items, var all items equals new. And then I'll just move this to the next line because it's going to be a bit more verbose. Yeah, like this perhaps. And then in each of these lines, instead of this, we're going to create new items, new actual items. So we will say new item, and here we will provide a name. So let's use something that we can use for this test. Like I said, let's go for the potion case. So we will have a potion there, and then let's add two more. This second one is going to be named, let's name it something completely different like antidote. And then the last one is going to be high potion. So in this case, we have two items that have the same term, potion, and another one that doesn't have it. And then we'll declare a variable here that we're going to say it's named name to match equals potion. Now notice that we are already implementing the test case for this new method, but the method just does not exist at all. It has not been implemented. So, and that's the right way of doing TDD. So we will start with a test case that will actually fail because we don't have the method, and then we will move forward to implementation later. Okay. So now when the repository invokes GetItemsAsync, we will return all the items that we have prepared in here. Remember, this is the call to the repository, it's not the call to the controller, GetItemsAsync. So then we go ahead and prepare our controller. And then comes the time to make the call to the act. Now here we're going to be a bit more explicit. The first is we're not going to be using var on the left side because we want to signal to the to C# and to VS Code what we're going to receive from this new method, a method to be created yet. So in this case, what we're going to receive is an I enumerable of item DTO. And this is going to be found items. And are we missing something? Yeah, season collection generic was missing. And then this is going to come by calling await controller GetItemsAsync. But not this signature. We need a new signature where we can actually itemsAsync. We need a new signature where we can receive the name to match. So we're going to pass name to match here. Okay. And yeah, so yeah, that's a method yet to be created. And then as our assert, what we want to verify is that we only got items that where their name match the name to match, in this case, potion. So to verify that, we will say found items should only contain, and then we can say item where item.name should be equals to item. Yeah, it will be items sub, sorry, so this is all items sub 0 dot name, because that's the first one. Let's scroll up a little bit. So we had 0 and we got 1 and 2. So it should be that one, or, and then I'll just copy this, should be item name should be equals to all items sub 2 dot name. Okay, so that's a way that you can use FluentAssertions to verify that the items in a collection match some condition. So whatever we're getting 4 items, the items should match either potion or high potion in this case. Okay, so if we go ahead and build this, so I'll do Ctrl+Shift+B. Of course, it fails because we don't have such a method, GetItemsAsync, that receives some argument. So that's kind of the red phase of TDD. And now to start moving into the green phase, we need to move forward and implement this method. To do that, what we can do is just click here. I'll do a Ctrl dot, and that presents these options. What we can do is just say generate method items controller GetItemsAsync. So I'll do that. And then if I do F12 here, the method now exists. And I'll move this up just next to the one that we have already, the other overload here. Okay. And then we could go ahead and try to implement this, but as you notice, these methods are exactly the same thing, but one of them receives a parameter and the other one does not receive it. So I think it's better to just put everything in this one method as opposed to try to implement yet a second one. So I'm going to just take this parameter out of here and into there, over there. Okay, and then we are not expecting to always receive the name. It depends on what the caller wants. So let's make so that this can receive null. So it is allowed to receive null. Okay, and so with that, let's go ahead and run our test case once again. Let's see what we get. I mean, at this point, it should build just fine. Let's verify that. It should build. Yeah, it does build. Now let's run the test. Yeah, and as expected, it is failing. Yep. It is failing because it is getting more items than expected, and on this, as a result, found items is just getting all the items. It's not getting only the ones that have been specified here. So let's see how we can fix this. So let's try to get green. So what we're going to do is something very simple. After retrieving the list of items, we're going to apply some filtering if we have to apply a filter. So if string that is null or white space name name to match. Actually, let's just rename this to name as opposed to name to match. That should be enough. If name is null or white space, yeah, if it is not null or white space, then we will apply a filter on the list of items that we have already received. So items is going to be items where item.name contains the name. And just to make sure that we don't worry about casing here, let's do string comparison dot ordinal ignore case. With that, it doesn't matter if you're looking for potions with capital P or with a smaller p. It shouldn't matter. We don't care about that. So as long as a name has been provided, it will be used to do a filter on the items. So we get a filtered list of items, and that should be enough to satisfy the condition. So let's go back to the test. Let's run it. Yep. And this time it is passing. So we are green, and let's actually confirm that this is true by running the entire test suite now and making sure that we have not broken anything. So yeah, as you can see, everything is green now, and so everything looks great. So that's how you can use TDD. We don't really need to do more refactoring here at this point, but if you needed to, you feel free to go ahead and do more refactoring. But we have gone through the red phase, green phase, and now refactoring is not needed in this case. What we can do now is to verify that this new functionality actually works in the real life. So we will start our host, and we will see how to use this from Postman. Okay, so I'll go ahead and hit F5. And then I'm going to Postman. Yep, over here. So let's see, to start with, let's see what we have currently in our database. So I have here the URL to get all the items in the database. So I'll hit send. And at this point, we have Mega Potion and Antidote. And we are already verifying that things are not broken because we already invoked this method that has been modified. It can receive a parameter now, but it seems to be working just fine. So to properly verify that the new functionality is working, I'm going to actually add yet another item here via the post action. So I'll just copy the URL, I'll say plus, I'll switch this to post, paste the URL, and in the body, I'll do raw, and I'll do JSON. And then I'll just copy the body of something else here. Copy this. Notice that the previous items don't have a description, and that's fine. The new item will have one. Let's make sure we can add one. So let's do this, that. And then to keep things simple, I'll just name this guy Potion, and this is going to be restores a small amount of HP. And the price is going to be, let's say, 7. So let's post this. Okay, it's there. And if we go back to our get operation, I hit send. Here we can see that we have the 3 items now created. So now is when we can see if the filtering is working. So now I can say that name equals, and I'll be looking for potion, right? So potion. So this should only give me the Mega Potion and the potion. So I'll go ahead and hit send. And indeed, we're only getting these 2 items. Notice that it didn't matter that I used a smaller p here and not the capital P that we have over there. It was still able to find the items. So things are working as expected. So yeah, that's how you can use TDD to drive your process to add new functionality to your REST API. So as always, I hope this was useful, and if you're looking into diving deeper into what I have covered in this tutorial series, please check out the link to my full online course in the video description. Leave me a comment if you have any questions or if there's something else that you'd like to see in this channel. Also consider hitting the like button if you're getting value out of this, and don't forget to subscribe if you'd like to know right away when I publish new videos. Thanks for watching, and I'll see you next time.